Hello, everybody. My name is John Williams. Today we're going to be doing an XFLR5 coefficients versus angles, lift and drag coefficients versus angles, and lift coefficients versus drag coefficients. An airfoil, a NACA 2415. We're going to create a wing with an aspect ratio of 6. And dynamics of these wings and airfoil. So let's get started. Okay, let's go to module, direct foil design 2415 right here. And we're going to have 200 panels. And this is right here. Now we'll go to module XFLR direct analysis. And now we'll go to analysis and define of 3 million today. Right there. Okay. And we will be doing our analysis settings. We're going to from -5 degrees. We're going to end it at 20 degrees. We're going to have 1 degree increments in between. Foil. You can see here we have our lift coefficients here versus our drag coefficient. We have, let's see, let's move this up over here. We have lift coefficient, the top of the wing, and we have the hinge. So, okay, so now we will export these. We'll just what we've got going on here. So right click here, and we're going to go to current graph, export graph right here. We will name this graph. Let's call it that. We will save. And now we can come down here and we can see we have final project here. We'll click on it and we're in Excel coefficient here. So what we're going to do is we're going to make a graph, come up here and let's see, right click, select data. We're going to dump what they have right. NACA 2415 and our series values, the y-axis. So we'll just get our data right here. There's our lift coefficient there. Okay, right there. And then there you can see. And okay, so let's go back to XFLR5 analysis here, batch analysis. This is so we can keep track of our Reynolds numbers throughout the span of the wing of the aircraft. Degrees, -5 degrees and a maximum alpha of 20 degrees, the increments of 1 in between. And now we will analyze. This takes a couple of minutes. And it's all done. So and now you can see from the span of the wing, how things change throughout the wing, the lifts. Okay, so let's go up here to modules. Let's go wing and plane design. Now let's go plane name. We'll just call this project 1. About the fins, you can take these all up, but however you can click on these, you can have the body of the aircraft, the biplane, and you can manipulate and play with all these different aspects. We have our main wing here. Let's define this wing. Okay, so we'll use an aspect ratio of 12, and we'll have a taper ratio of 0.5. This is the wing root, the fuselage, and this is the wing tip out here. Number 2 is the wing tip. So the wing length, 4.5 meters. We're gonna have a 1 meter chord length right there, and then we're gonna have half meter wingtip chord, 0.25. Okay, and then we'll use our foils, the outside, and here is our wing, 15 airfoil right there. It's pretty cool though. Okay, so now we will save this to analysis, define an analysis. We'll do this at 20 meters per second. This is going to be our airspeed, and we will come up here. We're going to start at -5 degrees and at 20 degrees with analysis. And there it is. You can see our lift coefficient versus our drag coefficient. We'll get this, click on it, and you can get anything you really want. Drag coefficient induced versus alpha. Okay, so you can change all that. We'll just do a lift coefficient. We're going to export this graph to lift coefficient and save it. Go here to lift coefficients, and we can start a graph again. Once again, we go to graph, add, say, CL, and here we go. This is our lift coefficient data right here. We're just going to get all that. X-axis, because we want our degrees, our alpha degrees here. And there you have that. 5 was 17. We can click on this. We can get a trend line here. Let's add a trend line. And there's the slope of our trend line right there. So that's pretty much what you can toy around with this and have a lot of fun with it. Okay. And we'll get